Good evening, students. In this module 2, we are going to discussing about lumped parameter analysis. Okay, that is the analysis of quenching of billet by lumped heat capacity method. Okay, in this, consider a billet which is quenched in a fluid. Okay, that is having m is equal to which is having a mass of which is having billet having a mass that is in kg. Okay, and v be the volume that is in meter cube, and rho will be the density of the billet, and cp will be the specific heat, and Ti will be the initial temperature, and T infinity will be the surrounding temperature. Okay, so we know that the temperature T, the billet temperature, which is greater than the surrounding temperature, right? So we are applying the energy balance equation. Okay, energy balance equation here. Okay, that is the rate of convective heat transfer, which is equal to decrease in the internal energy of body per unit time. Okay, so rate of convective heat transfer, which is given by H into As into T minus T infinity. Okay, T minus T infinity, which is equal to m Cp into dt by dt, that is decrease in the internal energy of the body. Here decrease is there, right? There is a decrease in internal energy, so negative sign. Okay, so rearranging dt by T minus T infinity, which is equal to minus H into As divided by m into Cp into dt. Okay, so here m is there, right? Mass which is equal to rho into volume. Substitute the m value. It is equal to minus H into As divided by rho into V into Cp into dt, that is dt by T minus T infinity. Okay, so on integrating the above equation. Okay, above equation, so 1 by T minus T infinity, which is equal to ln of T by T infinity, which is equal to minus H into As divided by rho V into Cp into T plus C1. Put it as equation 1. Okay, this is equation 1. And now apply boundary condition, that is initial. Apply boundary condition. The initial boundary condition will be, that is T small t, that is time t is equal to 0, and T caps T, which is equal to Ti. Okay, therefore ln of Ti minus T infinity, substituting the boundary condition. Okay, which is equal to minus H into As divided by rho V into Cp, here T, which is equal to 0, so the C1, therefore C1 will be ln of Ti minus T infinity, right? Okay, now substitute C1 value in equation 1. Okay, ln of T minus T infinity, which is equal to minus H into As divided by rho V Cp, that is specific heat, plus into T plus ln of this part Ti minus T infinity. Okay, so ln of t minus t infinity divided by ti minus t infinity, this part and this part, okay, which is equal to minus h into as divided by rho v cp into t, okay, rho v cp into t, which is equal to, now removing the ln part here, okay, so t minus t infinity divided by ti minus t infinity, which is equal to exponential of minus h into as divided by rho v cp into t, okay, and this is put it as equation 2, okay. Now consider only this powers of the exponential, power of the exponential term, okay, that is h into as divided by rho v cp into t, okay, and that can be rearranged in a dimensionless form by multiplying the values of v, k and as, okay. So h into as divided by rho v into cp into t, which is equal to h into v divided by k into as into k into a square divided by rho v square into cp into t, okay, this one part, okay. So we know that characteristic length LC the formula, right, LC, which is equal to volume of v divided by a, right, volume of the solid part and the cross sectional to the cross sectional area, okay, of that solid part. So h into as divided by rho v cp into t, which is equal to here, okay, h into, okay, v here, v divided by as is there, right, this part is called as LC, so h into LC divided by k, this part is called as characteristic length, so substitute the value LC, okay, and here k divided by, and we know the Fourier formula alpha, Fourier law formula, which is equal to Fourier law, that is thermal alpha, which is equal to the thermal diffusivity, okay, k divided by rho into cp, it is the value of alpha, okay. So here k divided by rho into cp, right, k divided by rho into cp here, so the above equation becomes alpha into t divided by LC the square, okay. So h into as divided by rho v into cp into t, which is equals to, this is Biot number formula, okay, this is Fourier number, so exponential of minus of Biot number into Fourier number, so okay, t, therefore t minus t infinity divided by ti minus t infinity, which is equal to exponential of minus of Biot number into Fourier number. This is one of the important derivation of lumped parameter analysis, okay, and remaining derivation we will continue in the next video, okay. Thank you.